Good day, grade 6. Today we'll be learning an interesting topic, the solar system. The solar system is made up of the sun, 8 planets, moons, astronauts, and comets. So the sun is at the center and the planets orbit around it. So let's begin with a quick question. What do you know about the planet? So I want everyone to put on their thinking caps and think about what they already know about the planets. So great, now that I heard what you guys already know about the planets, let's explore the solar system using a recycle model. Before I display the recycle model, the sun is also known as a star which provides heat and light to the planets. So the planets orbit around the sun and there are 8 planets. Now let's have a look at our recycle model. So this is our recycle model of the solar system. Remember what I said about the sun, which is like a star that provides heat and light to the planets. This is why we painted our sun orange, to give you a visual demonstration of how hot the sun is. Okay, and basically the heat and light that it provides to the planets. So now we're going to look at our planets in order. So first up we would have Mercury, which is closest to the sun. Next up we would have Venus, which is a very hot planet. Then the third planet is Earth, the planet which we live on, our home. Then the fourth planet is Mars, known as the red planet. Then we have Jupiter, our fifth planet, which is known as the largest planet in our solar system. Then we have Saturn with its beautiful rings. Then we have Uranus, which is our third biggest planet in our solar system. So this is basically a visual representation of how the planets would orbit around the sun. Then we have our last planet, which is Neptune. This is our planet which is furthest from the sun. Okay, so there are initially 8 planets, but we added another planet, which is Pluto, known as the dwarf planet.
So as we've discussed, we'll be learning the solar system as our topic. So as you can see, our solar system that we've represented here as a group and was discussed previously are based on these planets. In the center, as it begins, is the orange sun. Okay, the sun was painted orange in this case, and the planets are in shapes, are in different orders, and the first being Mercury, then Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and last comes Pluto. Pluto not being a planet, a dwarf planet. But in this case, we'll be learning why each and every single planet is different. So, to start off, each planet has its own orbit. An orbit means it moves around in a certain path different to one another and on a curved path. So, if you guys can think about that, each planet moves on its own different path, meaning that it takes its own time. So each planet takes its own time to complete a revolution. The inner planets, being Mercury, Venus, Earth, Mars, those planets are the planets which are closer to the Sun. The outer planets, which are Jupiter, Saturn, Uranus, Neptune, those planets are further away from the Sun. And as you know, the inner planets are small, rocky, and closer to the Sun. The outer planets are large, made up mostly of gas, and are far away from the Sun. This is why Jupiter, Saturn, Uranus, and Neptune look much bigger on our model. So, let's check what you guys have learned. Which planet is closest to the Sun? Which planet is one of the inner planets? And which planet is one of the outer planets? What does the word orbit mean? And can you describe it in your own words? So now I want to show you to use the model or I want you to create your own model. But in this case, I want you to go beyond of what we've done. I want you to create your own orbit in which you are showing the different orbits of each planet. So notice how each orbit, as stated before, has their own certain amount of revolutions. So I would like you guys to state facts on whether or not each planet has its own different type of revolution and how long it would take for that planet to complete a revolution. And today, learners, the Sun is at the center of our solar system. But just remember that there are 8 planets, each with its own orbit. We also learn that the order of the planets and the difference between the inner and outer planets are extremely crucial. Our recycle model helped us to see how these planets are situated in our solar system.
Thank you to my colleagues for that clear explanation of the planets and how they move. So, grade 6s, we've looked at the scorching sun and we've traveled from rocky Mercury all the way out to freezing Neptune. But if you remember from the beginning of the lesson, our solar system is made of more than just the sun and planets. For the next minute, let's look at the other members of our space neighborhood: moons, asteroids, and comets. First up, moons. Just like Earth has one moon that lights up our night sky, other planets have them too. But did you know that the outer planets, the gas giants like we've just discussed, have dozens of moons? Jupiter and Saturn have over 80 moons each. These are natural satellites that orbit the planet just like the planets orbit the sun. Next, we have the asteroid belt. Remember how we've learned the difference between the inner and outer planets? Well, there is actually a border between them. Between Mars and Jupiter, there is a massive ring of rock and metal called the asteroid belt. These are leftovers from when the solar system was formed. Think of them as space rocks that never quite became planets. And finally, we have comets. These are my favorite. They are basically dirty snowballs made of ice and dust. When they get close to the sun, they heat up and leave a beautiful glowing tail behind them. So, to wrap up our lesson and to bring it all together, we have the sun at the center, acting as the battery that powers everything with heat and light. We have the 8 planets divided into the rocky inner planets and the giant outer planets. And we have all the fascinating moons, asteroids, and comets filling the spaces in between. As you go home to work on the orbit model task that was assigned, I want you to remember that Earth is special. We are in the Goldilocks zone. Not too hot like Venus and not too cold like Neptune. We are just right for life. Thank you for exploring the solar system with us today.